Hello, my name is Haley Burns, and today I will be presenting the work I did for the Course One project for Machine Learning Foundations for Product Managers. Just a quick review of the project guidelines. I'll be building a model to predict the electrical energy output of a combined cycle power plant using the provided historical data. I will determine what type of machine learning approach is needed, select an appropriate output metric, determine what features to use in the model, and identify algorithms for consideration in order to get the best model performance. Additionally, since I'll be using AutoML for this project, some of these tasks will be automated. However, I'll still talk through them. The data will be split into training and test data, along with validation data within the training data. AutoML will choose a validation strategy, which I would recommend using cross-validation, because we have a relatively small data set. AutoML will also select the best model to use and evaluate the performance using multiple output metrics, but I will talk through my thinking around this as well. For the machine learning approach needed, we'll use the regression approach. This is because we're predicting the new hourly electrical energy output, a numerical value. We will not be using the classification approach here because we are not choosing something that is binary or out of a set. The output metrics best to use depend on the types of errors in the data and what we're willing to accept. From the lecture, we were asked the question, is it worse to be very wrong a few times or a little wrong a lot of times? Mean squared error tends to severely penalize large errors as opposed to mean absolute error. Mean absolute percentage error is good for non-technical audiences, but can be easily skewed. For our power plant model, I recommend we go with mean squared error because we don't want any major errors factored into our prediction. We will also want R squared to be closest to 1 when evaluation and comparison is taking place. When determining features to be used, we don't want to risk the quality of the model by removing important features, so we might want to engage a domain expert to validate that we're using the right features. We could also apply regularization and use the lasso method to remove features that are deemed unimportant in reaching our target. For algorithms to consider, we look at interpretability, accuracy, and computational efficiency. Linear regression is a recommended model to start with. We'll use multiple linear regression, and I recommend that we try to remove a feature for our second approach and see if the model performs better. I would also recommend we try something like random forest to see how that performs. Since there might not be a linear relationship between the features and the target, a random forest can be highly effective at predicting in those conditions. As I mentioned before, AutoML will be selecting the model we use, but we can train the model once with all features and then remove the least important feature to compare. If our output metrics improve with the feature removed, we can go ahead and select that approach. If not, we'll keep all of the features in our model. I've included some screenshots to show how I set up the data set for my model training. Here you can see I chose regression and uploaded the CSV file provided for the project. AutoML did some stat generation to show how many distinct values are present for each feature. I chose regression as the objective and PE as the target column. I kept RMSE as the default optimization objective, and I chose not to exclude any features from the training on the first round. You'll see at the end of the presentation that I trained the model again with one of the least important features removed to see if our model performed better. I set my budget at 3 hours and then 4 hours for the second training based on the recommendation, and my model took about 3 hours to train each time. Here is the first evaluation from AutoML with all features used. AutoML has selected the best algorithm and trained it based on the data I provided. You can see here that the data was split, output metrics are shown for the model, and AutoML also showed what the importance of each feature was in making the predictions. Now I retrain the model and remove the least important feature, RH. You can see here that I have a new set of output metrics to compare to my original model. In conclusion, here we are comparing the two models, and based on the output metrics like the lowest mean squared error, option 1 of our model with all features was a better fit. Also, you can see R squared for our first option is closer to 1 for this model. Thank you very much.